All right, good morning, physics class. This is day 68. It's June the 2nd, and we're only have two more assignments left. This is the second to last assignment. Wednesday will be the last assignment. Get every assignment in by Monday, June the 8th, and just get them done and get them going. Get as many in as you can. All right, so let's go ahead and talk about this. This is a nice little software program that deals with sound, and you can either record sound or have it generate sounds, and it's a good opportunity to kind of play around with sound and study sound. It's free. It is a download, so you need a computer on which you are able to download. I don't think that's true of the school computers, but maybe you have some other way to do this. And I don't know whether there's an app for the phone to do this, but it really needs to be done on a full computer screen to really see and use its full features. So we're going to go ahead and get started with this and do a few little projects on this. This is something normally I would have you do in class. I would give you computers from the classroom and you could go ahead and do this. So if you have a way of getting this on your computer, great. But if not, the assignment will really just involve watching me do it and doing a few, showing you a few features. All right, let's get started. Okay, so what I'm going to do is show you where to go to find it. It's simply called Audacity, spelled this way. But I would include the word sound because there are other companies called Audacity and you may get some other website. Okay, what you do is go into Google, type in Audacity, spelled Audacity, and type the word sound also because there are other companies called Audacity, and that'll bring you to this, to these links right here. And what you would do is just go ahead and click on download. It's not something that you can run off of their system in the cloud. And you have several options, Windows or iOS, or OS rather. So whatever is your computer, and then you can download it. But I'm going to just go ahead and do this with you. You do not need to do that for this assignment. All right, so when you download the program and then open it up, this is the home screen. This is what you will see, and I'll just show you a few features of this. So I'm not going to go through all of these features. You can find YouTube videos that will do that, but we'll go ahead and just play around with a few of them for this assignment. We'll focus on the assignment that I have for you. The first thing we're going to do, we're going to generate a sound, and we're going to generate a tone. And this is a sine wave. And I'm going to go ahead. It's a 440 hertz sine wave. And if you know music or you play a musical instrument, you might know this, that's an A note. So I'm going to go ahead and click on that. And you see it just looks like a blue bar going across. But what I can do is I can zoom out on that blue bar. And it by default gives you a 30-second blue bar. So what I'm going to do is I'm going to take these double arrows, kind of just follow what I'm doing. I'm going to move this over to the middle. Now, if I put it on these timelines here, you'll see it goes from 15 to 45 up here. That means it's 30 seconds. And I clicked it, so there it goes. You're hearing the sound it's making. And I'll go ahead and stop that. Now that's a little bit long. We don't really need something that goes that long. So what I'm going to do is I'm going to hit this I bar on the top. You'll use that a lot because that allows you to highlight what you want to work with. And I'm going to cut out about 15 seconds. Not exactly, but about. So you see I'm covering over from 15 to 30. And then there's a little scissors here, a little pair of scissors here. I'll snip that. And now I just have a 15-second wave. All right, now I'm going to cover over the whole wave. And we are going to, almost the whole wave. Let me try that again. Okay. And what we're going to do now is zoom in. Now, before you zoom in on a wave like this, you want to cover it over like that, or cover over the part of the wave that you want to be able to see. Otherwise, when you zoom in and it expands out, the thing you wanted to see might shift off the screen. You won't be able to see it. So, and I'll give you some examples of that later. So I'm going to just zoom in, and now you're going to see what the sine wave actually looks like. And it should look recognizable to you as a transverse type of wave. It's one of those roller coaster type of waves. Now, if you really remembered what we said about sound a couple weeks ago, sound is not a transverse wave. It's not the roller coaster type of wave. It is a longitudinal wave. It's the slinky type of wave that squeezes and releases, like a spring or, like a spring. So why do they show it as a transverse wave? And it's because it's simply easier to visualize what, where the high points are. It's easier to analyze the numbers. So you have a number scale over here on the left. We won't really go into what that scale is. It's just a number scale. But anyway, it's easier to visualize where the high points are and the low points. Whereas something, if they tried to illustrate a compression wave on the computer screen, it wouldn't really be clear where the exact high pressure point is, where the exact low pressure point. Here you can see exactly where the high pressure points, that's the top or the crests of the waves, and the low pressure, that's the bottom of the waves, okay? So we'll go ahead and play that. And you see as it's moving. So 440 of those cycles from the top of one wave down, back up to the top of the next, 440 of those are passing each second. All right, let's go ahead and also we're going to generate a square wave. Okay, and again, we'll zoom in on this, highlight over part of it so it stays on screen, and we'll zoom in. Okay, and there you go. There's a square wave. What this is telling you is when you see that, it means it's really not a smooth sound. It's really a lot of little beep, 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 beep sounds put together so tightly that you can't hear one from the next. So it sounds like a consistent sound, but it's really, it really is beep, 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 really, really fast. So let's go ahead and listen to this one. Okay, so you can hear it's kind of has a not so pleasant sound. And that's because the sound is coming and going and coming and going, up and down, up and down, up and down. It's not a nice smooth curved wave like a sine wave. So that's what a square wave would sound like. Now we're going to go back to the sine wave, and we're going to do a little experiment here. We're going to play around with having two sine waves at the same time. So we're going to generate tone, have to switch it back to sine. 440, we'll go ahead and use the A. We could use other frequencies, but we'll go ahead and use this. And again, you see it's trying to go off the screen, so I'm going to pull it over there. Now remember, this is a 30-second wave. So I'm going to I-bar, cover it over so it stays on screen. All right, and let's go ahead and cut off again about 15 seconds. We don't need that much. So I'm going to click here. I'm going to drag that over to there, hit the scissors again. Now we have a 15-second sine wave. Again, we play it so you can compare it with the square wave. Okay, a much smoother sound than the square wave. All right, now what we're going to do is we're going to add another track, a mono track, meaning it's only one sound. It's not stereo. It doesn't have double sound like a stereo speaker would. And we're going to go ahead and put in another sine wave. And we'll move it over so it's right underneath the first one. Right there, and then we will go ahead also and cut off so it's also okay. So here are two 440 sine waves, and the first thing I'm going to do is just move one of them a little bit so it's not directly lined up with the one on the bottom. And now we'll cover them both over, and I'm going to zoom in, and there they are. And now what we want to do is I'll click on the double arrows again, and I just want the bottom one to move, but it's not doing that, so I want to click on it actually. And now the double arrows. And I'm going to move just the bottom wave So the crests of both waves are directly above and below each other, and the troughs, that's the bottom part, the crests are the top, the troughs are the bottom, will be directly above and below each other. So that means that the crests ought to be adding together and the troughs ought to be adding together. What that'll do is make the sound twice as loud. So I'm going to zoom out. Okay, and I'm going to go ahead and we want to play these waves together. Okay, so you could hear how when they were both being played at the same time, it made a louder sound. It doesn't exactly sound louder. It sounds a little funny, but they were twice as loud. And then when it passed the top wave, it was only playing the bottom wave. Then it didn't sound as loud. So that's what happens when you add two waves that are in phase. Now what I'm going to do is I'm going to put them out of phase. And let's see what happens. To cover the waves over. And I'm going to zoom in on a specific point right here. Now what I'm going to do is I'm going to shift one of the waves. Now let's just click on the bottom wave here. And we are going to grab our double arrows and we're going to shift it so the top of the bottom wave is directly below the bottom of the top wave. So you can see in this area the bottom of the top wave is directly above the top of the bottom. I might have to move it one more. It's hard to do this exactly. You'll notice that the top of the top wave is lined up with the bottom of the bottom wave. What that means is they're going to cancel out. You're adding a positive number to an equivalent negative number. So positive 3 plus negative 3, for example, will give you 0. And everywhere along these two waves, they're going to zero out. So I'm going to zoom back out again, and we're going to hear the two waves being played at the same time. So this is called destructive interference. These two waves are said to be out of phase. But when one is going up, the other is going down at any time. So I'm going to zoom back out again. And I'm going to go ahead and play them at the same time. At the beginning, you're going to hear just the top wave. Then you're going to hear them play at the same time when you see them overlapping here. And then at the end, you're only going to hear the bottom wave. So let's go ahead and see what that sounds like. Okay, so what you heard is that when only the top wave was playing, it was a normal sound. When they overlapped, it got a lot quieter. Actually, it should have been 0. It should have been next to nothing. But it's hard to really line these up by eye and just get them to line up perfectly. But if I could have lined them up perfectly, you'd have heard no sound at all. You definitely heard, though, how it got quieter. So that's destructive interference. Again, let's zoom in and take a look at it. Oops, I'm going off screen, so again, I have to do what you need to do is always get your eye bar and cover over both of them, and then zoom in, and that'll keep them on screen. So we're seeing how the destructive interference worked. Again, it's not perfect. I don't have them perfectly lined up, but pretty close, and you got a sense of that. Okay, we're going to move on to another project now. Okay, now I'm going to do something that I wanted you to be able to do in class. I'm going to record my voice. And you're going to see what my voice wave looks like. And we're going to kind of analyze that voice wave, do a little bit of analysis on that. So here goes. I'm going to record it on just believe it's just going to be mono. It might be stereo. Let's go ahead and do that. Hoover High School. All right, so there's my voice wave. Let's listen to it. We'll play it back. Hoover High School. Okay. All right. Now you see the wave got a little big right here when I said high. That's called that's clipping, and that is something you don't want it to do, but it's okay. It doesn't kill it. So what I'm going to do is cover over the ver in Hoover right there, that second syllable in Hoover, and I'm going to zoom in on that, and you'll see what my voice looks like. And it's really kind of a zigzaggy kind of a wave. Now what you'll notice is it does seem to be repeating. So let's go ahead and take a look at that. I'll zoom in one more time. So you notice there's a real high peak right where I'm circling the cursor right there. I'm only looking at the top wave here. It is in stereo, and that's fine. They're just duplicate waves. So right there is a high point. Now remember we said a cycle is from the high point of a wave to the next crest over. So from the crest of one part of the wave, go down, come back up to the next crest over. So what is one wavelength here, or one cycle? Well, is it from here down to here? Or is it from here to here? Or to here? Well, you can see that there's kind of a twin of this, and you have to go over to here. So between here and here is one cycle. Between these two highest points right there is one cycle. So what is all this other stuff in between? Because it does seem to go up and down here. We'll talk about that in a minute. But this is truly a cycle of my wave, is to go from this highest point to this highest point. So what I'm going to do is I'm going to cover that over, just that area, and I'm going to zoom in on it. So notice it stays in the middle of the screen. Now those high points don't look so high anymore, but we can still see where they are. So what I'm going to do is I'm going to record how much time. If you look at up here where the little finger is pointing, I'm going to try to guess how much time that is right above that first highest point. So where that line is, it's right where that line is pretty much, and it's 1.9180. I'll move the hand just so you can see the number clearly. It's this number right here. 1.9180 is pretty much right where that hand is pointing. So I'm going to write that down. So that's the beginning of one cycle of the wave. Now I'm going to move over here, and the next one is over here. And it's right there where that finger is pointing. Now that's not right on one of the little lines up above. So you see there's a line at 1.9270, and then the next number to the right is 1.9280. So I'm going to estimate that that's 1.9272. Not 1.9270, but 1.9272. All right, so that is what's called a period. It's the time it takes for the wave to go one cycle, and that's called the period. So we're going to do a little analysis with that. We are going to subtract the higher number from the lower number to figure out what that period is for the wave. So 1.9272, that's the higher number, minus the lower number, which is 1.9180, and that gives us 0.0092, so 0.0092. That's the period. Now, if you remember from our discussion of waves, the reciprocal of the period is the frequency. So I'm going to go ahead and take the reciprocal of 0.0092, and what I get is 107. So that is the frequency of my voice, is 107 cycles per second, or hertz. Now let's see if that's a reasonable number, if that's within the reasonable range of a human voice. So what I'm going to do is I'm going to stop and go back to Google. Okay, and in Google I'm going to type in the question, what is the frequency of a human voice? And up at the top there it gives. It's 85 to 180 hertz. Well, that's for the typical male. So let me read it. The voiced speech of a typical adult male will have a fundamental frequency from 85 to 180 hertz. So mine is in that range. It's 108. Tends to be a little bit on the lower end, but it's right in that range. And that of a typical female is from 165 to 255. And what I've always done in class is had one boy and one girl come up and say Hoover High School, and we computed the frequency of their voices, and they, without fail, have always fallen within the proper range. For the girl, it was a little higher, maybe a little bit over 200, and for the boy, it was kind of in the mid 100 range. So we go back to Audacity, and you can see that that's where I was. I was at 107. All right, and so what are the rest of all these ups and downs here? Those are called subharmonics or overtones. And that's why if there was another person who also had a fundamental frequency of 108 hertz, that their voice would not sound exactly the same as mine. It's why an A note on a violin sounds different than an A note on a piano or different than an A note on a guitar, is because they have different overtones. They have the same fundamental frequency, 440, but they have different overtones. And so we're going to go to something, we're just going to look at one graph here, and it shows you the loudness of my voice compared to the frequency of my voice. So this is called plot spectrum. Oops. Oh, it's telling me not enough data because I covered that small little area. So let me go back out, and let me go ahead and cover the entire area here. Okay, and now we're going to plot the spectrum. And there it is. And so if you look at this down at the bottom here of this graph, you see what that is the frequencies, the different frequencies of my voice. And you can see there's all kinds of frequencies of my voice. And if I come along here, they go all the way up to the very highest ones on the furthest right are close to 18,000, over 18,000. The highest pitch, the highest frequency sound that a human ear can hear is 22,000. So my voice goes all the way down from 0 all the way up to around 18,000. It has all these little overtones that you couldn't even hear, but they are a part of my voice. Now if we go back here to 100, or actually let's see where 107 is. Okay, so right now I have the cursor at 108, and it's right there. It's this first highest point. That's the fundamental frequency of my voice. The 100, and we said it was 107 actually. It's 107. But you'll notice that there are subharmonic overtones that are up at 220, and again at almost 440. So you notice my voice almost has kind of an A note quality to it, because 220, 440, we talked about 440, but the next lower A note below 440 is 220. The next higher one is 880. Let's see if this is close to 880. No, it's actually up close to 1500. Okay, so it doesn't necessarily do that, but these are all the different frequencies that are in my voice. But the fundamental frequency is the 107 that we talked about. So you can have a lot of fun with this. I'll just show you one more thing. If you've heard an electric guitar, first of all, I'm going to close this. I'll just open a new one. And if you've heard electric guitar, I'm going to go ahead and generate another sine wave, same old thing. Click on that. And now you can go to effects, and let's go ahead and do that. I'm going to do a reverb, and you're going to see how that changes the shape of the wave. And I'll just take whatever the default settings are. Okay, let me actually zoom out and cut off some of this wave. We don't need it to be quite this long. Okay, so I'm going to cut off, I don't know, about 20 seconds of it. That's enough. We'll have 10 seconds left. Okay. All right, so let me cover this over. Let me space it out a little bit by zooming in. And let me go ahead and do the effect of the reverb again. And let's hear what that sounds like. Okay, so that was a reverb. We can also do an effect called a, what else do they have there? A wah-wah. Let's try a wah-wah. Okay, let's listen to that. Okay, so you see, and you can see that there's quite a few more up there, and you can play around with those, and you can learn a lot about sound. If you see, when you go on, if you play with this, if you see a term you don't know, I don't have time to talk about all these, you can just go on to Google and look it up and say, what does that term mean? You know, what is a compressor? What does auto duck mean? Things like that, and you can learn a lot about sound recording and about sound in general. Okay, so I'm going to wrap up this lesson. And I hope you learned something. I hope you found this was a little bit of fun. It's just not as much fun if you can't do it yourself, but if you do have your own computer, try to download this and do that. So I'll have some questions to go along with this. Go ahead and finish those, and you only have one more assignment to get done. All right, take care. Have a good day.